Hello friends, I am Mr. Harshal Warade, Assistant Professor from Sanjini College of Engineering, Kopargaon. Today we are going to learn the next part of Unit 1, that is tolerances. Why tolerances are to be studied, what is the need of studying tolerances, what is the need of giving tolerances to the manufacturing components. Let us learn today. So limits, feats and tolerances today we are going to cover. In this unit, limits, feats and tolerances. What are the definition? Let us see first one by one. So limit. These are the extreme permissible sizes within which the operator is expected to make the component. We know that the component drawing or a production drawing of a component is available with an operator. So operator is going to manufacture, or operator manufactures the component, makes the component as per the given drawing. So the maximum permissible sizes or dimensions within which the operator is expected to manufacture the component is nothing but the limit of that component. Feet. So what is the feet? It is the general term used to signify the range of looseness and tightness of mating parts. We know that the manufactured components, they are going to be assembled in order to form an assembly or a system. So whenever we are going to manufacture and assemble the different components, then the degree of looseness or tightness of these mating parts is nothing but the relation feet in between those mating components. Then tolerances. So allowable variations from the specified part dimensions that are permitted in manufacturing, that is called as tolerances. The tolerance is the algebraic difference between the maximum limit and minimum limit of a hole and a shaft. Now maximum limit and minimum limit of a hole and a shaft, it can also be specified, that is the tolerance can also be specified as the difference between the upper deviation and lower deviation, and it has an absolute value without any sign. So these are some technical definitions we are going to learn in next part. Let us see here tolerance dimensioning. Tolerance is the total amount that a specific dimension is permitted to vary. We know that it is the difference between the maximum and minimum limits for the dimensions. Now, for example, a dimension is given as 15 plus minus 0.002. It means that the manufactured part may be of 15.002 inches or 14.998 inches or anywhere in between these limit dimensions. So it is going to vary in between this range, that is 15.002 or 14.998. In between this range it is going to vary. So why tolerancing is necessary? Let us see. It is impossible to manufacture a part to an exact size or geometry. We know that practically it is difficult to produce the perfect components with perfect sizes, and any attempt towards perfection leads or results in extra cost of that component. So if the dimensions are to be maintained within a very close degree of accuracy, then a lot of time will be consumed on it. So there arises a need of mentioning some system within which the components need to be manufactured. So functional aspects of component can be achieved even without going for exact dimensions. In case of mass production, some amount of variation is going to result. During the assembly of two components, a kind of permitted variation has an important significance. We know this, and this no two things in the nature can be exactly identical. Hence the knowledge of tolerance, limits, feats and allowance is important in the field of production, and hence we have to we have to provide the tolerances. Tolerances are nothing but a permission to avoid the perfection in manufacturing. Let us move further. Assemblies. Parts will often not fit together if the dimensions do not fall within a certain range of values. So from assembly point of view, there must be some amount of tolerances to be given, means some amount of variation in the sizes, but not beyond those dimensions or variations should be allowed. Let us move further. What are the different types of tolerances? So geometric tolerance is the maximum or minimum variation from the true geometric form or position that may be permitted in manufacture. See, different geometrical features we have studied: flatness, circularity, cylindricity, straightness, position, concentricity, parallelism, perpendicularity, angularity. These are the different geometrical features of any manufactured component. So if there is maximum or minimum variation which is permitted from true geometric form, then that becomes geometric tolerance. Specific tolerances. The tolerances for single dimensions may be specified with the dimension based on one of the following methods. So whenever we want to provide the dimensional tolerances, means tolerances for dimensions, then that become dimensional tolerances. So they can be specified in the specific way, that is unilateral tolerances and bilateral tolerances. Let us see one by one. So unilateral tolerance. Variation from the specified dimension is permitted only one direction, either positive or negative, but not in both the direction. See here, I have shown a figure where the shaft having diameter 2.5, let us assume it is there in mm. So permissible variation is also mentioned here, plus 0.010 and minus 0.000. This is only on one side of the given dimension. Now bilateral tolerance. See, variation is permitted in both positive and negative directions from the nominal dimension. It is possible for a bilateral tolerance to be unbalanced. Let us see here. See example. Bilateral tolerance. So again, the example of shaft I have taken, 2.5 mm is the size, and plus minus on both sides 0.005 mm variation is permitted. This can be balanced, means plus minus same on both sides, or it can be unbalanced, like 2.500 plus 0.010 minus 0.005 as shown in the given example. So this is case of bilateral tolerances. Let us see here the important terms. The nominal size. What is meant by nominal size of a component? A dimension used to describe the general size of a component is nothing but the nominal size. Basic size is nothing but the theoretical size used as a starting point for the application of tolerances. So that is basic size. Actual size is the measured size of the finished part after machining or manufacturing. So that becomes the actual size of component. Here are few references. By making use of these references, we can have further readings related to this topic. Thank you.